thanks WoodSolutions for inviting me, for inviting all of us here today. I think these events are a fantastic opportunity to get together and to be louder and to listen to stuff. Let me push this in, maybe that's better. So it's my pleasure to share my experiences working with timber and on this particular project with you today. I'm wearing several hats. I'm architect, but I've also been the owner of this project and the owner builder. So I'm looking at it from a few different perspectives, I guess, which can be interesting. So it's a Hutt 01 passive house. It has won quite a few awards, which of course is a great thing. The basic design parameters in this house are, number one, biophilic design. So you can see in this image already that connection between inside and outside, super important for us, and that carries through the whole project. But secondly, of course, sustainability, which is also why a lot of the awards that we won were sustainability focused on this project. To give you a bit of context, north is to the left, and the side is the little triangle that we see there. It's a residential zoning, but accessed off a tiny bluestone lane. And there is a 10-story apartment on the south side of the building, cascading down to 4 stories right next to the house. And the house kind of mediates between that and the single-story dwellings on the other side. So it tries to create a better urban design as well, I guess. In the aerial, you can see how the site is wedged between the train line and the bluestone lane. And with the train line, of course, there's acoustic requirements, and we were looking at solving that, but also building boundary to boundary means we were looking at a prefabrication system, and they are some of the reasons we arrived at CLT construction as a methodology for this project. In line with our philosophy with biophilic design and with sustainability in mind, we also make extensive use of timber in our projects. Because with our projects we want to make the world a better place, for want of better words. Our own house, we built that as our own house, but also as an inspiration to others. So the house is a Passive House Premium, which is the highest category in Passive House. We've also carried out an embodied carbon assessment, and we've ended up on the highest rating on the Letty scale, which means basically it's a positive contribution rather than a negative impact that it has on the world. So you can see sustainable design is our most important driver, and of course there's reasons for it. So you can see this is really close to my heart. We have a real responsibility, I believe, to do something. The house is on fire, like Greta said, and every project counts no matter the size. Residential construction makes up to 30% of the Australian construction industry, so even a small project like this can make a difference, I believe. This talk is not about Passive House as such, but because Passive House is an important part of this project, I wanted to briefly touch on Passive House. The reason we do Passive House is mainly for optimal thermal comfort and to create healthy environments, but of course also as a side effect almost, it reduces energy by up to about 90%, which is a great benefit, so energy bills are really low, of course. Passive House is an envelope-first strategy. There's 5 principles to it. 4 deal with the building shell, creating a super efficient building shell, and the 5th one then helps with the indoor air quality and maintaining a comfortable and healthy temperature. The 5 Passive House principles are, number 1, airtightness. As you can see here, these are the wall build-ups of the house, so we've got a CLT structure, and then the red line is really creating our airtightness layer. And on the outside then we've got, on this side, we've got brick veneer, and on that side we've got charred timber. And then next to the airtightness you've got the insulation. So both these layers need to be all the way consistent. They can't be interrupted in a Passive House. There can be no disruption to that. And that's the 3rd point, basically, thermal bridge-free construction. So you can't have any interruptions. You see that insulation is going through from the wall into the floor. We've insulated on top of the concrete slab in this case because it makes for an easier detail in Passive House, and I believe a better detail, so that's why we did that. And the remaining thermal bridge that we see there with the red dashed lines is really very minor, so that is an acceptable thermal bridge. Number 4 is windows. You need high-performance windows. In Passive House PHPP, we have an energy balance for each window, where we look at if it gains energy or loses energy, basically, and that way we know if it's a good window or a bad window at the end of the day. And then finally, once we've dealt with the building envelope with those 4 principles, the 5th principle is the heat recovery ventilation system. So what it does is it brings in fresh air from the outside, takes out the stale air from the inside. They cross-pass in a heat exchange unit, and that way we can keep the temperature stable inside the house. So we can keep 90% of the energy in the house that's already there. And I think it's a fantastic technology that everyone should employ as much as they can. Last winter we had 5 degrees outside, 22 degrees inside, and the air that was coming through the heat recovery ventilation system without adding any additional heat to it set at 21.5 degrees just by reusing the heat that's already in the house. So it's free heating that you get basically for your building. And in Victoria we have a heating climate, so it kind of makes sense to do that. But I want to talk about our responsibility with regards to climate change, and one of the things that help us is timber. Timber is a material that can help a long way, as long as of course it comes from a certified source and we know where it comes from and we know where it goes afterwards. And I thought I might focus on the 3 main components of this house. Number 1, CLT, cross-laminated timber. Number 2, the timber windows, and then the wood fiber insulation. Some of you might have seen our journey of creating this home on Grand Designs Australia, and so I thought it'd be great to start off with Peter Madison's views on CLT and hear what he has to say.
To get a building permit in any town, any city in Australia, you have to perform to a certain environmental level. It's part of the building permit process. But passive houses like this one take sustainability to a whole new level through a raft of different elements and applications, including rainwater harvesting and solar collection and storage, etc. But let's start at the core of this issue, which is CLT, or cross-laminated timber. CLT forms the absolute heart of this house. Here we have a floor plate with 1, 2, 3, 4, 5 layers of CLT, and each element is at 90 degrees to one another, and that makes incredibly strong building elements to form floors, walls and stairs. One of the best things about CLT is the wood itself contains half its weight in carbon, locked up for its life. Also, it takes no energy to produce. It grows naturally, as opposed to steel or cement or glass. So we have here a material that's sustainable to make, easy to erect, and forms a beautiful finish that talks to you in a biophilic way. That is, we have emotion as humans that react to this wonderful material. It's pretty good stuff.
Yeah, he's right. It's really good stuff. It's a beautiful material. It's extremely solid, which is also something I really like about it. We don't only use it in this project, but also in others, because people like that solidity, a lot of people. But with that solidity, of course, also comes mass, both thermally and acoustically, which helps us again, because we're right on the train line here, to separate the noise from the train line. With the prefab, it's very quick installation, only 7 days in our case. And it could have been even faster if we had had more space, but you can see the access is actually quite tight, so we had to reduce the panel sizes rather than doing full wall lengths. And so each crane lift we budgeted 20 minutes, and we had 180 pieces, so you can do the maths that it took a week and a half roughly to get it up. But it's still a good result, I think. So detailing for the manufacturing then goes hand in hand with the engineer. Shop drawings can be done by the engineer or the supplier. And in this case, we were the supplier ourselves, so we did the shop drawings for it. And during that process, you get to decide things like the shiplap details and the joint locations, which are things that you will see later on if it's exposed. So it does have a real impact on the finished product and is very important to be considered at this stage. Interesting here, the falling ridges that we see due to the angled side boundaries, so some quite complex building geometry. It's a bit like a jigsaw puzzle, and our 3D file that we created for the shop drawings came from our BIM file, and that was then used by the manufacturer directly to feed the CNC machine. So very important to get it all right and make sure it's correct. Structurally, it gives you a lot of more opportunities, like the attic spaces that we've created, where you would normally have large trusses, whereas in this case you can actually fully utilize that space because the CLT sort of carries itself, and that really helps. Even though they're quite unforgiving and stiff panels, I think the worst spot we had was about 8 millimeters out at the far end. And considering there are no right angles because the house just follows the wedge-shaped land, I thought that was a pretty amazing result. And this also enabled us to create these schedules directly off our Vectorworks model, which we used on site during the installation a lot because they have the installation sequencing number and the little 3D and the panel number. So it was always the quickest way to identify each panel quickly and ensure it goes to the right spot on site. I created a little movie also to discuss the installation order with the installers beforehand, and so that we can get that loaded into the container in Europe in the right order before we ship to Australia and then unloaded here. And what's great is that once the CLT structure is up, it's almost airtight itself. So thinking back at those Passivhaus principles, you can potentially get away without using any membranes, depending on your detailing. Of course, all this makes cost comparison difficult. It's always the first question when clients come to us. Does it cost more? Does it cost less? CLT, my experience, is going to be a bit more expensive than traditional timber frame construction, but probably on par with or cheaper than concrete. But then you can create extra spaces like these attic mezzanines. It's extra room for no cost that normally would have been occupied by structure. So you take that into consideration and the whole picture changes. You can leave off some finishing trades like plastering, you can save on membranes, all those things. So if you want to compare, you need to compare properly and take all that into consideration, I believe. I like to say CLT is a bit like a solid piece of furniture. It's beautiful, it's natural, and while it could fall over a piece of furniture, it will not easily break when it's done well. And that makes CLT also great for earthquake areas, and there has been some testing done internationally on that front, and I think there's a huge opportunity there that we're seeing. Also great fire properties, as if you watch our Grand Designs episode, you will find out more about that, but I'll leave that to the side for today. I said it's a bit like a piece of furniture, so you can then finish it. We have whitewashed it to maintain that white feel, that light feel. But of course you can also go with darker colors, fully paint over, whatever you want to do to finish it off. Once finished, it is beautiful to look at. You do get that biophilic design aspect. So we've got the connection between inside outside, we've got the inbuilt planters in the house, the green walls, all those sorts of things. But we also have that natural material, that timber of the CLT, that is a solid timber surface that you can touch. We've taken a zero waste approach as much as possible, so you can see the HRV ducts that need to run in the hallway ceiling. We've basically dismantled all the shipping sledges and shipping pallets and taken those boards and used them to create this suspended ceiling here that matches in with the CLT. So it looks as if it was CLT, and it's made from waste material. So that's, again, a great opportunity for sustainable design. Of course, we need to make sure it comes from well-forested sources. Regrowth is guaranteed. The whole chain must be, you must be able to see that, and you must be able to know where it comes from and what happens to it. But if you do that, it's a super carbon-friendly material. And with it being so solid, of course, you can fix stuff to it. And in our case, that's these beautiful nets that we've fixed everywhere. That would have been hard to do without CLT. So again, great opportunity. And there's limitless applications. So we're also doing a medical practice at the moment with CLT. So you can use it in commercial applications, and financially that's actually an advantage there because it is cheaper than concrete. But you also have some limits when you go into commercial because you need to deal with combustible surfaces and all those things. But yeah, basically limitless opportunities. And that takes me to my second point, the timber windows. You see here those large windows enable the connections between outside and inside. So what we see here is a master bedroom connecting through to the roof garden. And again, that's helping the biophilic design aspects. And of course, the bigger the window, the better it needs to be. So they're really good windows, high-performance windows. And again, I would like to say, let's hear what Peter Madison thinks of these windows.
Windows and doors are usually the weakest link in making a house perform well, but not here at this passive house. A lot of thought's gone into it. We have in this house a window and door system that comprises triple glazing, so that almost no heat is transferred from the outside to the inside environment. We have doors that are like a piece of Swiss engineering. Triple seals to stop any infiltration, a door locking system that starts at the foot of the door and runs right to its head. So when it closes, it is like a bank vault. In addition, these doors also act as windows. So a twist of the handle and the door becomes a hopper window, allowing all the hot air that may be in this room to escape naturally. What a great system.
What a great system. Thanks, Peter. I love his enthusiasm. It's always good. So on the next picture here, we can see the construction image on the bottom left-hand side. So what we've done is we've taken the timber windows and shifted them outside of the structural layer and put them into the insulation layer. And the reason for that was to really mitigate any thermal bridges and get rid of any thermal bridges as much as we can. It makes for great detail from a building physics point of view, but also really hard detail to make it work on site. So given the relatively mild climate that we have in Melbourne, I probably wouldn't do that again, and just sort of shift them slightly back into the structural layer. The other four images show the same sort of windows, just in a finished, when they're finished. These are timber windows, so they can be left to grey out. They can be left to grey out. I'll come back to that a bit later. Why timber windows? That's because they are the best from a performance point of view. What we see here are temperature profiles for aluminium windows on the left-hand side. It's cold day, about 0 degrees outside, so the surface temperature on your aluminium on the inside, even though this is double glazed, would be about 6.5 degrees. On this one, the same window, but a thermally broken profile, already you get 15 degrees, so huge difference between these two. But then once you go to timber, to high-performance timber windows, our surface temperature on the right there is almost the same as the internal air temperature, and that's really what you want, so you don't want that difference between them. So that's why we love timber windows, and that's why I believe that they are the best you can do. This is an interesting little comparison again. I find first column there shows us aluminium double glazed window, U value of 4.4. Let's jump to the third column, 2.2. So that's double the performance basically, or half the energy that you would use or that you would lose through that window. And when you compare it then to the high performance window that we've been using in this project, it's 6 times the energy consumption or saving. So huge differences. Choosing the right window is super important, I believe, and we have a long way to go on that. Unfortunately, we couldn't afford the local ones price-wise, so we did import ours. This is one of the ones that we import, and this is actually the only frameless passive house window on the market in Australia. So frameless means on 3 sides of the window you bring your insulation and your facade right up to the glass. So all you see from the outside is the glass and a little aluminium strip at the bottom, and then the window opens to the inside, and that's how it works. So it's beautiful architecturally, and it's a great detail in terms of thermal bridging. So something I can highly recommend. The other thing you can see here is that the timber itself is actually engineered timber rather than just a solid section, and that means you don't have to get your sander out every 3 months when the weather changes to make sure the window closes again, but this will actually work by itself without having to be readjusted every 3 months. What we see on the left is the window detail for the window on the right. So again, we've got the CLT layer, and then the airtightness in front of that, which connects to the window. And then on the other side of the insulation layer, we've got a fairly deep cavity to create some external shading that is concealed within the facade. It's a fairly big window. This one is a north-facing panorama window, about 4 meters wide, but of course they're flexible size-wise. They can be fixed or tilt and turn. They can be lift and slide doors like these ones, and it's usually tilt and turn or lift and slide because they are the only ones that give us really good seals and that make sure the window actually sits into the frame as much as possible. Apart from the seals, the windows and doors have minimum of 3-point locking mechanisms in these high-performance wooden windows, which means it's also a safety aspect. So you can't actually break into the house easily because the door holds or the window holds. They can be left, like I was saying earlier, they can be left to grey out. So in this case, this is large here, and that has been oiled to start off with, but we'll leave it and let it grey off over time. But you can also have them painted. They usually come pre-finished. And the finishes last up to 20 years. So I've installed similar ones in Germany over 20 years ago, and they're still good, except for one on the weather side that had to be repainted a couple of years ago. But these finishes are very good when they're applied, not on site, but beforehand. And number 3, wood fiber insulation. Again, a beautiful natural product, but also I would like to let Peter Madison do the intro for that one as well.
Let's talk about insulation, because it has such a big part to play in making a building perform well. And on this passive house, the outside skin is just so important. So the system comprises cross-laminated timber building core, structural core, then building paper adhered to that CLT to stop any air infiltration. Then 140 millimetres of wood pulp, which really does a lot of the hard lifting. Another layer of building paper, and on top of that some timber battens and metal skin. What a system. It works so well, and it makes Passive House a great way to go.
It makes Passive House a great way to go, that's right. So wood fiber, natural products. It's not like other insulation types that are itchy when you're touching them, that are byproducts of the petrochemical industry. This is actually made from natural wood fibers, so you put a pile like that together, and that then gets mixed with wax or resin depending on the recipe, and then pushed together to create these rigid boards that you can then use on the outside of your structural layer to create a thermal bridge-free insulation layer. There's different, it will decompose, so in its afterlife, once the house gets demolished, if it ever gets demolished, it can be composted, it will decompose, and so it's a true cradle-to-cradle approach with this thing. Because it gets compressed so much, it is quite a dense material, which again means it has a thermal mass component that helps with overheating, so not just insulation, but also overheating is looked after with this better than with traditional insulation. And it also helps as acoustic mass, of course, against the train line again. There's different applications. It could be rendered directly or installed with a membrane and cavity, like we've done it, shown on the left here. We've also installed it as floor insulation between the stories for acoustic purposes, so that's possible too. But really, we've wrapped the whole house in it. So basically, coming up the walls, over the roofs, coming down the walls, and then across on the floors, which comes back to those 5 Passive House principles. It needs to be a continuous layer, and you see that red line indicating the airtightness layer around that. If you're doing Passive House, you know, the red pen test, so you're not allowed to drop your pen basically when you draw that. And it looks easy in this section, but there is actually a cross section going the other way, where we've got the CLT, and then on the outside of the CLT you have that red line normally, but in this case we have the garage roof, which is another CLT layer coming in that rests on that, so you need to interrupt that red line. And what happens in that case, you just need to put a little bit of membrane in first before you bring that CLT in. So while the CLT is installed, you need to think about those things beforehand. Because CLT is almost airtight itself, it's relatively forgiving in that sense, but it is better to do it that way. About 20 years ago, people in Germany, when they had started to insulate their houses better, they discovered the problems that come with it, and one of those problems is mold that started to appear. Australia is a much easier climate, but there's still a little bit of a risk, and wood fiber insulation helps with that because it is breathable. It does allow condensation through. So what happens in that case is warm air can hold more moisture than cold air, and as the temperature drops on a cold day from the inside 21 degrees, outside 5 degrees, that moisture can't be held anymore, and that will become water, will become condensation inside your wall frame. And if you have an insulation like polystyrene on the outside of that, that moisture won't be able to get through that. It won't be able to get out of your wall again. Whereas wood fiber allows that moisture to travel through. So it definitely helps in that regard. Breathability is a big part, but if unsure, there's calculations, woofy calculations that you can do to make sure you're on the right side. Unfortunately, I spoke to a lot of people in the timber industry here if they want to go in a joint venture with me to produce wood fiber insulation locally, and I would love to do it, but no one has taken me up on that offer yet. So we're still importing it from overseas at this stage, but because it has all these advantages, I think that's worth doing. And then finally, there's the cladding. So on the outside, we've got the charred timber, and on the inside, it's cradle-to-cradle certified boards. So it's a house full of timber. It's nice to touch everywhere. Helps with mental health and mental well-being, being biophilic. But of course, we need to make sure it's from the right source, like we were saying earlier. That's probably one of the most important takeaways for this. And that really brings me to the end of this talk. If you're interested in more detail, we do offer house tours, so you can contact me. There's a waiting list. And there's my contact details there at the bottom. If you can't read them, just go to melbournedesignstudios.com.au and you'll find it there. And we're also about to launch some courses for carbon zero housing and passive houses. These are courses for both end customers and professionals. And if you've got an interest in that, feel free to contact me, drop us a line, and we're happy to have a chat. And the last thing I want to say is let's make the world a better place with timber. Thank you very much.